You hear about data-driven decisions all the time, right? Well, that's just the finish line. Every single one of those decisions is the final step in a long, messy, and often totally hidden journey. So let's pull back the curtain and see what it really takes to make data useful.
Take a look at this number, $12.9 million. What do you think that represents? Is it a company's profit? A big new investment? Nope. It's actually the average amount of money a company loses every single year because of one single pervasive problem.
That's right. Gartner research found that this is the average annual cost of just bad data. That's money just poured down the drain. We're talking marketing campaigns sent to the wrong addresses, huge business strategies built on shaky numbers, and just countless hours wasted by people trying to fix simple errors. This all points to a fundamental truth. Most data, in its raw form, is basically a mess.
To really get our heads around this, let's use an analogy. I want you to think of data as water. It's a vital, essential resource, but before you can use it, you have to collect it, and you definitely have to purify it. So, let's take a look at where this water comes from and what makes it so contaminated. So data is generally collected from two main sources. First, you've got primary data. This is like digging your very own well for a specific purpose. You're getting fresh, first-hand information from things like customer surveys or specific experiments. Then you have secondary data, which is more like drawing water from a river that's already flowing. Someone else, like the government or another company, collected it for their own reasons, and you're just tapping into that existing source. But here's the thing. Whether that water comes from your private well or a public river, it's rarely clean enough to drink right away. Raw data, no matter where it's from, is often packed with problems that make it unusable. In the industry, there's a simple name for this: dirty data.
And these pollutants come in a few common flavors. You've got your basic inaccurate data. We're talking simple typos, misspelled names. There's incomplete data, where a crucial piece of the puzzle, like a zip code, is just missing. Then you have duplicates, where the same customer is listed 2, 3, or even 10 times. And finally, you get stale data, information that was once correct, but is now just old and irrelevant.
And the scale of this problem is, well, it's huge. According to IBM, a staggering 80% of all data that gets collected is what they call dark data. This is information that companies gather, pay to store, but then never actually use for anything. It's like having these vast, untapped reservoirs of water that just sit there, costing money but providing zero value.
Okay, so we've got all this murky, contaminated water. Data. How do we turn it into something clear, reliable, and actually useful? Well, this is where we need to build our own data water treatment plant.
The official term for this whole process is data cleansing, and it's pretty much what it sounds like. It's all about systematically going through a data set, finding all those incorrect, incomplete, or irrelevant records, and then either fixing them or just getting rid of them completely. This is the purification stage.
And this isn't just some random scrubbing, It's a very systematic process. It starts with a data audit, which is just finding all the weird spots and anomalies. Next, you create a workflow to plan exactly how you're going to fix everything. Then, you execute that workflow, which is the actual cleaning process. And finally, you do a little post-processing to verify that the results are in fact clean.
Let's just zoom in on one of those pollutants for a second. Incomplete data. Missing information isn't just a minor annoyance. It can lead to totally flawed conclusions and just create chaos in everyday work. So how do we fix those gaps?
One of the most powerful techniques is something called imputation. Now, it's a statistical term, but the idea is actually pretty brilliant. Instead of just deleting a record with missing info, you intelligently replace the missing bits with estimated values, all based on the other data that you do have. And here's exactly how it works. On the left, before imputation, Jane Doe's record is missing a zip code. That makes it really hard to use for shipping or for any kind of location analysis. But after imputation, look at that. The system sees the city as New York, and it intelligently fills in the most likely zip code. Just like that, an incomplete record becomes whole and way more valuable.
So our data is now sparkling clean. It's been purified. But what good is clean water if it's just sitting in the treatment plant? Now we have to get it to the people who actually need it. We have to deliver it.
This is the job of a data pipeline. And you can think of it just like a city's water system, with all its pipes and pumps. A data pipeline is an automated system that transports all that clean, treated data to its final destination, whether that's a database or an analytics tool where people can finally turn it into insights.
And these automated pipelines are absolutely critical for any modern business. They're what enable real-time decisions.
They ensure that everyone is working from the same high-quality information. And they can scale up as the amount of data just explodes. Having a good pipeline isn't just a tech detail. It is a massive competitive advantage. Now, these pipelines can operate in a couple of different ways. You have batch pipelines, which are kind of like a scheduled delivery truck. They process huge chunks of data at set times, like maybe once a day. Then you have real-time pipelines. These are more like a continuous stream, processing data the instant it's created, which is totally crucial for things like detecting fraud as it happened.
The way these pipelines are designed often comes down to one key question: when does the cleaning happen? The traditional approach is ETL: extract, transform, and then load. You pull the data out, you clean it up, that's the transform part, and then you load the purified version into storage. But a more modern approach is ELT: extract, load, and then transform. With this, you load all the raw, messy data first, and then you use the incredible power of modern cloud systems to transform it right there where it's stored.
So what's the big takeaway here? Well, data, just like water, is absolutely essential. But for it to be truly valuable, it has to go on this complex, unseen journey. From being collected like water from a polluted stream, to being purified through cleansing, and finally being transported through pipelines to a clean tap where it can finally be used to power real insights.
So the next time you see a chart or a statistic that claims to be data-driven, just remember this hidden journey. Remember the massive effort of collecting, cleaning, and delivering that had to happen just to make that one little insight possible. That's the unseen but incredibly important journey of data.